Good afternoon, everyone. This is Chauncey Goss. I'm chairman of the South Florida Water Management District. It's September 9th, 2020, and I'm going to call the Governing Board workshop to order. We really appreciate you joining us for this workshop. It's going to provide an overview of the C-139 projects. Just to remind folks, this is informational only. The board's not going to be making any decisions today. Members of the public, if you'd like to comment at the public comment period of the workshop, you can use the raise your hand feature in Zoom. And if you're having any trouble and you need help, please go to our website, sfwmd.gov, and click the Ask Us button at the top of the page, and staff will be happy to help you out. If you're using a phone and you'd like to comment, please press *9 to raise your hand and *6 to mute and to unmute. And as a courtesy to others who wish to speak, members of the public are asked to comment only once on any one item. I'm going to ask the board to raise your hand if you have a question or a comment, and I'll sort of see how the flow of things go, and I'll either let you ask a question during the presentation or at the end. I'd like to remind the board and the staff to keep your mics muted unless you're speaking. And we'd like to have a hard stop on this meeting at 4 o'clock, if not before. And now we're going to go to the Pledge of Allegiance. And Mr. Steinley, if you're available, I'd love you to lead us in that.
I am available. Thanks. I pledge allegiance to the flag
of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Thank you, Mr. Steinley, for doing that. Now we're going to get the workshop started, and I'm going to turn this over to Jennifer Reynolds, who's our Division Director for Ecosystem Restoration and Capital Projects. Jennifer?
Good afternoon. Thank you, Chairman Goss, board members, and members of the public who've joined us today. We have an interesting workshop agenda. Stephen Collins and I are glad to bring this workshop agenda to you today. There are no decisions for you to make. Instead, we wanted to provide you some information and context about a part of the district that we haven't talked as much about recently. And so here on the map, you can see Lake Okeechobee at the top of the map and the Everglades agricultural area in the middle. And what we're going to talk about today are the areas that are just to the bottom left-hand corner of the slide where it says C-139 FEB and Sam Jones Abiaki Prairie Restoration. So that entire portion, the two red splotches with the green in the middle, that area is called the C-139 Annex property. And it is the subject of our workshop today. Rosie, if you could go to the next slide. The reason that we're bringing this workshop to you today to talk about these projects is because we will have several governing board agenda items, one tomorrow and then several coming up in the coming months that have to do with these restoration projects and upcoming projects for the board to consider. And so why we wanted to bring them to you today is so that you can have the context of what these projects are all about. They're each a little bit different. They have different funding sources, different ways of going about the planning, and they're really unique projects in their own right. And so we're excited to bring them to you today. Before we go into the specifics of each of those three projects, in the north, the flow equalization basin that later Jose Otero will present. In the middle is the proposed area under the Western Everglades Restoration Project. That's a SERP project, and Mindy Parrott will present that later today. And I wanted to publicly thank Mindy for coming in off of leave. She had a leave scheduled this week, and so she joined us today in the midst of her leave. So thanks, Mindy, for doing that. And then on the south end of the property, our first project that we will talk about is the Sam Jones Abiaki Prairie Restoration Project that Jesse Van Eyck will present. But before any of them go into the specifics of those projects, first, Carmela Bayregal is going to present a little bit of information to help you understand what the difference is between the C-139 basin and the C-139 annex. as well as talk about the hydrology of this area that we're going to talk about today. So I will turn it over to Carmela. Thank you.
Hi, Carmela. Can you unmute your mic, please?
No. Okay. Hello, good morning, good afternoon. My name is Carmela Bedregal. I am sorry for the delay. I am the section lead at the Everglades and Estuaries Protection Bureau. And as Jennifer described, today's Governing Board workshop will present on key projects in the Western Everglades basins. And at the heart of these projects is a district property called the C-139 Annex. The map that you see here shows the project area, and you can see Lake Okeechobee to the north, the EAA to the south, and the area of interest, the C-139 Annex to the southwest, as Jennifer showed. The key projects are located within the C-139 Annex, or they expand across it. To place these projects into the context of all the Southern Everglades tributary basins, please take a look at this map. The Lake Okeechobee is here, the Everglades agricultural area to the south, and to the southwest is the C-139 Annex Basin. The Flow Equalization Basin, the Sam Abiaki Prairie Restoration, and the Western Everglades Restoration Project, WERP, will benefit 3 of the Southern Everglades Basin. The C-139 Basin, which is located here, the L-28 Basin, and the Feeder Canal Basin. So how will water quality be improved? And for that, we need to look at the hydrology of the Western basins, how water flows from one basin to another. So this map is similar to the previous maps that you have seen, except that it indicates main surface water structures and canals. And let me get my pointer option here. So the C-139 basin to the north is here, and the southern portion of the C-139 basin flows to STA 56 from the north and from the west. Next is the Feeder Canal Basin. The west part of the Feeder Canal Basin flows to the southeast and discharges from the area at the west weir. The north part of the Feeder Canal Basin flows south and discharges through the structure PC-17A. Discharges from the north of the Feeder Canal Basin and the west of the Feeder Canal Basin mix and travel through the Seminole Big Cypress Reservation. Finally, discharging from the Feeder Canal Basin at S-190. Finally, let's talk about the L-28 Basin, where the C-139 Annex property is located. The C-139 Annex discharges south, and from there, it discharges into the rest of the L-28 Basin at the USSO structure. Water further flows south and discharges to Water Conservation Area 3A at the S-140 structure. The projects that you will hear next will reroute or improve the conveyances that you see on the screen, resulting in water quality improvements. This slide further zooms into the basins And a description in more detail of the projects that take care in each of these basins is provided in Chapter 4 of the South Florida Environmental Report. On the top left is the C-139 basin. As discussed in the previous slide, the basin currently discharges to STA 56. What Jose will be describing now or next will be the flow equalization basin, which is the hatch area here on the southeast of the slide. With the FEV in place, flows from the C-139 basin will be able to go into the FEV prior to going to STA 56, improving STA performance. On the bottom left is the feeder canal basin that you saw before. As you recall, we talked about flows from the feeder canal basin going south and southeast. With the WERP project that Mindy will be describing, one of the benefits may be that a portion of the North Feeder Canal flows may be directed to the C-139 annex. Finally, the L-28 basin, where the C-139 annex is located, is presented in the middle, including the C-139 annex FEV on the north and the Sam Jones the Sam Jones restoration on the south. And in the middle, the lands that you see here in the middle are the lands that are being considered for incorporation into the Western Everglades Restoration Project and may receive some of the flow from the feeder canal basin. Finally, these projects that you will hear about next add to other existing initiatives. And what this table does is it summarizes the current district source control approaches and other projects. So the C-139 FEV will add to the treatment train that we have of best management practices conducted under district permits, a total phosphorus annual load compliance metric, and the existing stormwater treatment area 5.6. For the L-28 basin, the current approach is having the landowner that is currently a lessee in the C-139 annex conduct BMPs under an environmental resource permit. And the district also tracks the performance, the total phosphorus levels in discharges from the L-28 basin and compares it to planning levels that we have. The projects that will occur in the C-139 annex will reduce stormwater discharges from the L-28 basin and the C-139 annex in particular. For the feeder canal basin, the current approach has been implementing BMPs through environmental resource permits in the North Feeder Canal Subbasin, and for the West Feeder Canal Subbasin, BMPs are implemented through the Florida Department of Agriculture and Consumer Services BMP program. These activities are conducted towards reaching a goal of 50 parts per billion of total phosphorus in discharges, and the WERP project will add to this treatment train. So this completes my introduction. Additional detail on the activities conducted by the various entities in these basins is presented in the South Florida Environmental Report. And I don't know if I can take any specific questions or comments at this time, or we can leave those for the end. Thank you.
Thank you. Are there any board members who have a question? If you do, raise your hands and I'll recognize you. Okay, seeing none, let's move on.
Great, thank you.
And next we're moving to current and future projects with Jesse Van Eyck, who's the lead engineer and construction manager for the Engineering and Construction Bureau. Jesse?
Good afternoon, governing board members. Thank you for your time and opportunity to present on this great project. My name is Jesse Van Eyck. I am, yes, a lead in engineering and construction manager in the Engineering Construction Bureau. I'm also the project manager for the C-139 Annex Restoration Project that we'll be discussing today. First off, let me start by saying that's one of the first things you'll notice that's different is sometimes you hear C-139 Annex Restoration Project and the Sam Jones Abiaki Prairie Project. I'll clarify that a little bit later in the presentation, but I do want to acknowledge that the screen says something different than what I just said. In today's presentation, I'll briefly cover the history of the project, including its acquisition. I'll also review the project funding source. I'll illustrate the different projects located on the property. You've already seen these slides, but I'll dive into those a little bit more. And hopefully I can clarify some of the multitude of activities that are going on at this property. I'll discuss the goals of the restoration project, and I'll review the restoration work we've performed to date, as well as the work we're going to need to do going forward. Towards the end of the project, I'll turn my presentation over to my colleague, Rob Hopper, who will discuss wildlife and vegetative restoration on the project. So you've seen this, this map on the right already a few times. We're talking about this, the red and green holiday inspired color scheme that's going on the left side of STA 56. The property is located on the north side of the Big Cypress Seminole Indian Reservation. So we acquired this property in 2010, October of 2010. And the property itself is about 18,000 acres. We purchased it as a citrus grove, and it remained as a citrus grove under lease until the various lands could be adopted by different projects. Some of those lands are still under lease, and I'll cover that a little bit more. So here's a little bit better breakdown of the land use. On the north end, as Carmela mentioned earlier, we have the FEB, or the flow equalization basin. That area is about 2,900 acres, and that'll be discussed later today. I won't get into that too much. My presentation will focus on the other two components, primarily the yellow area, the Sam Jones Abiaki Prairie Restoration Project, and some rerouting we need to do in the green area. That green area is labeled as leased agricultural lands. And as I said before, those are citrus groves that were remaining in lease until we can appropriate those lands for another use. And one of those other uses right now is a potential STA under the Western Everglades Restoration Projects. So that green area is about 6,600 acres that's available for future land use. And the Sam Jones Abiaki project is about 7,800 acres. So the Sam Jones Abiaki Prairie, also known as the C-139 Annex Restoration Project, will restore that 7,800 acres of citrus grove into a historic rainfall-driven wetland habitat. It'll remove exotic plants, it'll improve wildlife habitat, recharge groundwater, improve water quality going to the L28, and it'll also construct a seepage management system at our southern boundary to safeguard the Big Cypress Seminole Indian Reservation. So a little bit about that name, naming the C-139 Annex. And I'll take a moment just to read off the slide here. And it says, the name of the property, the naming of the property is Sam Jones Abiaki Prairie was suggested by the staff of the Seminole Indian Tribe of Florida, or Seminole Tribe of Florida Historic Preservation Office. They felt the name was appropriate given the importance of Sam Jones to the local community, given the fact that Sam Jones town was once located in the scheduled area, scheduled lands to be restored. And that came straight out of the fall 2013 volume of the Atatiki Quarterly magazine. This is a tribal magazine put out by the Tribal Museum. It's primarily located on the Big Cypress Reservation. So who was Sam Jones? Sam Jones was a kind of like a spiritual leader for the tribe. He was a leader during the Seminole Indian Wars, and he was notorious because he refused to surrender to the U.S. Army during the wars, and he was actually never caught. So He was able to, safeguard a number of people from the U.S. armies and move them out of sight and really kind of keep the distance. So for that reason, he became a legend in tribal history. And so we're honored to have this property named after him. So the project funding. Non-district funds will be used to reimburse the district for land acquisition costs related to the restoration project, as well as fund the construction and long-term maintenance of the restoration project. So a little on that non-district fund that I mentioned. Florida legislature established a mitigation fee for each ton of limestone and sand sold in the Miami-Dade Lake Belt area to finance mitigation efforts to offset impacted wetlands affected by the mining activities. The Department of Revenue then collects that fee from the Lake Belt and transfers those fees to the Lake Belt Mitigation Trust Fund. The Lake Belt Committee, which was established under state legislature, oversees the expenditures of those mitigation trust fund, The Lake Belt includes representatives from the district, DEP, FWC, Miami-Dade County, the Army Corps, EPA, Fish and Wildlife, and even a non-voting member from the Miami-Dade Limestone Products Association. So what is the project goal? What are we trying to do exactly? Well, as we mentioned before, this property was primarily a citrus grove. And we have a 7,800 acre part of that parcel that we want to convert into a wetland. So that sounds pretty easy. And we're gonna create about 4,300 functional units of wetland mitigation by doing that. But as simple as that sounds, it's actually very involved. And I'll try to take you through some of that today and what that effort requires. So just to kind of give you a scale of this effort. This slide shows that Sam Jones Abiaki project, which is 7,800 acres, is equivalent to 12.2 square miles. Those of you in the West Palm area may be familiar that with Royal Palm Beach, and Royal Palm Beach is 11.7 square miles. The whole area of Royal Palm Beach is 11.7 square miles. And on the bottom right of that is district headquarters. It's a little dot on the map. You can't even see HQ in relation to Royal Palm Beach. And that's what we're looking at the Sam Jones Abiaki Prairie. Similar for those folks that live a little bit further south, I'm a Broward guy. So the Dania Beach area is an area that's more familiar to me, and that's 8.3 square miles. And you can see our Fort Lauderdale field station in that photo. Again, a little blip on the map. I say that because by the time we're done with this project, we will have in some way had a human contact with just about every square inch out there. This is a restoration project. So we literally have to walk this by foot, turn each bed over by hand practically, and replant this site. So it's quite involved. And that's really why I want to focus in on what the scale of this project is. Because after you look at these things on paper a few times, you start to lose that perspective of size. So project phases. You'll hear in various scenarios about phase 1 and phase 2, and I hope to clarify that a little bit. I'd like you to draw your attention to the yellow area that says phase 2. And I'd like for you to think of phase 2 as a footprint that also includes phase 1. So essentially phase 2 is the entire project footprint, and phase 1 is a component of it. And that is, phase 1 was our early works efforts. It's not a standalone restoration phase. It was just an early works area that we started back in the 2015 timeframe. So I kind of mentioned earlier that the property was renamed in 2013. And I'd like to just take a moment to kind of give you a time scale of the things that we went through. We started our coordination, formal and informal, in 2013. We got our phase 1 preliminary authorizations in 2015. We started working on those areas in phase 1 since 2015. And while we were doing that, we also were applying for and coordinating with all the various agencies to obtain our permits by 2020, just recently completed this year. And that's really important because this has taken us a very long time just to make sure we coordinate and we get it right. So we started in 2013 and gone through this all the way to 2020, 7 years of permitting. So planning approach, Citrus Grove to a restored wetland. This is, I'm not going to go through every step here, but this is to kind of give you an idea from that last slide, what it takes to take a citrus grove and turn it into a wetland. We have about 27, 28 steps here outlined. And that phase 1 effort that we did took us to step 18. So in the 5 years that we've been working in phase 1, we got to step 18. And now that we have our permits for phase 2, we'll take it through step 27 and we'll repeat this step for every acre that's out there. So what goes into this overall design that's coming forward in the phase 2? Well, in phase 2, we'll build our seepage management system, which will include a seepage pump station, as well as 3 step-down weirs and a road at the north end of the property, which is that dotted blue line at the top. Those features will essentially bound the project and give it some walls. And those walls will contain the restoration area. To do that, we'll also have to redivert some water that came into this area, which I'll cover a little bit later. On the inside of those restoration components, we have this slide again, which I showed you earlier, phase 1 and phase 2. On top of that, we have these restoration areas. And as I mentioned earlier, phase 1 was just a component of the project. And you can see in restoration area 1, or Abiaki 1, that the green area doesn't quite fill in this whole Abiaki 1. We have a little strip left that we need to do, as well as build some of that infrastructure on the south end. So again, that was one piece of the overall puzzle. I mentioned we had to redirect some water. While the FEB is up here at the north end, I'm not going to focus on that. That project is already under its way, and it's going to re-divert this water that's already currently up there. And by water, I'm referring to the storm water. So currently, the way that the Citrus Grove had this set up is that in area 3, I'll focus on area 3 and area 3 and pond 3, which is in this diagram here. So area 3 used to flow from the west side of the site to the east to a common header canal. Then it would move south into our future restoration area and get pumped into pond 3. When pond 3 would fill up, it would overflow and it would discharge across the site through a canal and get pumped into pond 5 south. From pond 5 south, it would move to L28 through the USSO structure. And this is the headwaters of L28. So we obviously don't want the stormwater from this, the leased lands area or the future WRP area, moving down into our restoration project and crossing it and interfering with the project. So we need to reroute that. Luckily, we have a lot of existing infrastructure at our disposal. And so we can redirect that water pretty easily. So I mentioned we had the seepage controls before, but now we need to move water a little bit differently. So we're going to install these 4 fixed weir culvert risers. Those risers will enable us to move that water from the west to the east side of the site in the green area and have it pumped into a above ground impoundment, which will then flow through an interconnect weir that we'll construct and into pond 5 south and down to L28. While I'm on this, there's also the restoration project will have several gravity structures, and the water will similarly flow from west to east by gravity through several gravity structures, and any excess water that is above and beyond the norm will flow by gravity out to pond 5 south and out through L28. So this is where we start, and I've shown you this photo before. Again, orange grove. We need to start by removing those citrus groves, citrus trees, and start treating for exotics. And in this slide, you can see a photo from our project itself, where we've removed citrus trees, and you can clearly see the beds and the drainage ditches, and then the next bed, and so on and so forth. And you can see where we've been treating the weeds in preparation for our next step. And here's the next step. We start leveling. I got a little video here. And in this process, you'll notice that we're not pushing a lot of material. We're just pushing a little dirt at a time from the bed into the ditch. We peel these beds back like an onion, 6 inches at a time. And we revert that material, push that material directly into that adjacent ditch. This is done to make sure that we get the really clean stuff at the bottom to end up on top of that ditch. This was a method approved by FWS and during a pilot study we did back in May of 2015. And it proved to be an excellent way of identifying any concerns they had, but it also gave us the ability to not laser level the site, but instead to reverse engineer the site and simply restore what was pre-existing. And restoring that pre-existing condition allowed us to return the underlying micro topography, that nuanced topography, which we'll show you a little bit later today. We also start to remove the drainage features that are on the site. I mentioned those ditches earlier, and those ditches are conveyed to these black culvert pipes and drain the farm bed. So we start removing all that black 8-inch culvert pipe and removing those farm bed drainage features. Because again, we're no longer farming citrus anymore. We're now working towards restoring these lands as a mitigation project. So once we remove these culverts, we then start filling the farm lateral canals, the farm bed lateral canals, these larger conveyance canals that were meant to divert stormwater away from their citrus trees. We filled one canal, lateral 15E, and I'll talk about that in a little bit, to date as part of our pilot study, because that canal was no longer needed for any kind of on-site water management. It was simply dedicated to the farm beds. So I've already kind of shown you some of the phase 1 completed item photos and give you a little sneak peek at what we've been doing. But just to kind of recap, we removed and leveled 2,800 acres of farm beds in the phase 1 footprint as part of our preliminary works. And you can actually see in this photo, the Seminole tribe is on the left side. So this photo is looking kind of northwest. And we did this in 2016, 2017 timeframe. As part of that, we were able to remove 21 irrigation wells and reestablish that microtopography I mentioned earlier. In 2018 and 2019, we started backfilling that lateral canal 15E that I spoke about. We removed the existing water control structures that were along that lateral canal. We excavated 2 deep water refugia areas to generate fill material to fill that canal. And we backfill it to the adjacent natural grade. And by saying that, if you look in this photo, you can actually see the canal in progress as it was being filled. And we surveyed both sides of the canal and then filled it to match that interpolated value of those 2 survey points. So that way we could, again, restore that natural topography that was underlying. And in doing that, we were able to create a rookery with an island in the middle. And Rob's going to talk about this a little bit more later, so I'll leave that for him. But it was a really neat feature, and you can almost see this D. It's like the District Dunkin' Donuts D. It's kind of a neat feature. Some people look at it as a gumdrop. It's really kind of neat. And this is our method for moving forward for generating our fill material for filling our canals. Here's a photo from the ground of what that looks like on site. So the equipment in that photo is sitting in the island still. We haven't finished digging out the island. And you can see the moat that we've started to build. It's a pretty good size. But work on the annex never stops. So that was 2019. So in 2020, even amongst a pandemic, the work continues. We put out and advertised a clearing effort to get rid of citrus trees in the next area that we want to start preparing. And so we currently have about just shy of 1,700 gross acres shown in the green and blue areas on this slide that are actively being cleared right now. Tomorrow, you'll actually have an item under consent for a change order to add some additional acres to the west for your consideration. We'd like to expand on this clearing effort just to keep the project going and ahead. Moving forward, as I mentioned, we'll need to continue to backfill those remaining lateral canals that are throughout the phase 2 area. We'll have to modify that surface water system and decommission those existing ag ponds like I noted in pond 3. We'll construct the seepage management system that we talked about earlier. We'll also replace the existing discharge structure or USSO structure with a new G771 structure. That's a new structure that will be located in the same vicinity and it'll follow the district's naming convention instead of the old purchase convention. We'll also clear and level ag beds and install water control structures. We'll continue to decommission those actively used irrigation wells, as well as plant with appropriate native vegetation, and we'll continue our exotic removal and monitor and adapt as needed as we go on. And we expect all this to be completed in 2028. So with that, I'm going to turn over my presentation to my colleague, Rob Hopper, who will discuss some of the wetland and vegetative functions.
Good afternoon, everyone. My name is Robert Hopper. I'm a senior scientist with the Land Stewardship section here at the district. And today we're going to discuss completed items in phase 1. So the first item we will discuss is hydrology. In phase 1, as Jesse mentioned, site leveling has been mostly completed. The result is a gentle, nuanced topography. In this slide, you can see some subtle ponding going on, and that's what we want to see. It creates the perfect foraging area for this roseate spoonbill. The next topic is site revegetation. At Abiaki Prairie, we try to leverage technology to increase productivity. In this case, a sod sprigger typically used to plant ball fields has been modified to plant large areas of native maiden cane grasses. And in this image, you can see a planting area just 6 months after installation. We're getting some really great coverage. Native maiden cane is a really resilient native plant, and it works very well for restoration because it stabilizes our grades, and it also starts adding organics back to the soils. We like to refer to it as our primer coat for the wetland restoration. To this, we add littoral plantings, and we install them around the remnant wetland areas that are on the site. So on the slide to the right, you'll see more typical plants that you would expect to see in a wetland. In this case, sawgrass. These are sawgrass plugs that we're installing. And on the left, you see some additional plants. These are some of the 23 different littoral species that are being installed around the remnant wetlands. And we expect these plants will migrate and span throughout the site. Wildflower and diversity plantings. Unfortunately, many wetland plants have been eliminated from the site due to years of agriculture. So what we really need to do is we need to restock Mother Nature's pantry. What staff does is we collect seeds from district natural areas and we grow these out to inoculate the site. You can see some photos here on the left of some of the wildflowers that we're planting on the site. We've planted 41 species of wildflowers to date. And on the right slide, you can see some of the grasses we're planting. We've established about 11 species on site at this point as well. As with the littoral plantings, we're hoping that these plants will set seed and expand throughout the site. On the left, you can see one of our diversity planting areas, and you can see the yellow coreopsis flower, which is the state wildflower of Florida. You can see some beautiful yellow goldenrods. You can see pink marshmallows blooming in the distance. And again, if they're blooming, hopefully they're setting seed. And this is something that we hope is going to expand and colonize the site. And in fact, on the slide to the right, you can see this happening. Those pink cotton candy plumes are on a muhly grass plant that's actually reseeded itself on the property. So that's very encouraging. We're always looking for efficiencies. So we've begun to also work directly with seeds and mechanical planters to scale up production. We're testing native wildflowers seeds, hibiscus seeds, plume grass, and native mixes. You can see on the right, the slide shows the native sunflower harvest area and me for scale. This is an area that we've begun harvesting this species from on district lands. On the left slide, you can see those seeds that we've harvested beginning to germinate in phase 1. And at this point in time, they're really tiny in the slide, but at this point in time, they're about 5 to 6 feet tall. And we're expecting a really nice bloom next month in October. The next topic is wildlife. So turning construction areas into wildlife habitat. We're always looking for ways to include biology in the construction process. And in this case, we're looking for opportunities to not just create bird foraging habitat like we saw at the beginning of my presentation, but also to create bird breeding habitat. And if we could think like a wading bird, what would they want us to design? Well, wading birds would want a forested island to nest on, surrounded by a moat patrolled by alligators to keep out nest predators. And as you can see in the orange box on the left and the close-up of that box on the right, the wading birds and alligators have already moved into this area. So that's a very encouraging proof of concept. As we can see in wildlife camera photos from our land manager, Jason Huckabee, wildlife is definitely returning to the restoration area. Here we see a family of sandhill cranes out for a stroll. In this image, we have a healthy bobcat, a curious deer and one of the hammocks on site, and a very photogenic coyote posing for a selfie. This is an image of a mother bear that is on the property and her 2 cubs. And finally, a photo of a mother panther on the property and her 2 kittens. You can see the glowing kitten eyes and the kitten on the lower left of the image. And also, if you look very closely on the lower right corner of the slide, you can see a second kitten with its little glowing eyes there as well. So in fact, after 20 years of field work, I saw my first Florida panther in phase 1 of the project. So Mr. Chairman, that concludes our presentation. We'd be happy to answer any questions.
Thank you very much, Jesse and Rob. Those great presentation, very interesting. Are there any questions from any board members on this? All right, I don't see any raised hands right now. We may come back to you. If we do have some more questions, and thank you very much for your presentations. I want to remind the public that we'll have time for public comment at the end. We're going to move on now to the C-139 flow equalization basin, and Jose Ortero, who's the section administrator for Everglades and local projects section, will take over that. Jose?
Good afternoon, Chairman Goss, and good afternoon, governing board members. I appreciate the opportunity to present to you the background, design, and current status of the C-139 flow equalization basin. My name is Jose Otero, and I am the section administrator for Everglades and local projects coordination at the South Florida Water Management District. I'm also the program manager for restoration strategies. Let me get my pointer. Second, please. All right. Okay, the C-139 Flow Equalization Basin is an integral part of the 2012 Restoration Strategies Regional Water Quality Plan that came to be known as Restoration Strategies. In September 2012, the Florida Department of Environmental Protection and the South Florida Water Management District entered into consent orders to build, expand, and repair STAs, FEBs, and conveyance features, and to collect data to show that the water quality-based effluent limit, also known as the QVAL, is met. Along with those consent orders, federal and state permits were issued by the department to allow the district to operate the STAs while the Restoration Strategies projects are being built, while still achieving good treatment performance. Once the Restoration Strategies projects are completed by the year 2025, the STAs individually must begin to meet the QVAL. The C-139 FEB is necessary for STA 5.6 to meet its QVAL. The hydrologic purpose of the FEB is to attenuate high flows from the source basin and extend the dry season flows from the source basin. The FEB is also one of 29 projects to advance Governor DeSantis' Executive Order 1912. This map shows the Restoration Strategies projects categorized into three major flow paths: the eastern flow path, the central flow path, and the western flow path. The C-139 FEB shown here is the final Restoration Strategies project that will be constructed in the western flow path. This map shows the footprint of the C-139 FEB in relation to its surrounding hydrologic basins. To the west is the Feeder Canal Basin, the north portion of that basin. To the north is the C-139 Basin. Also shown are the Deer Fence Canal and the L3 Canal that convey runoff from that basin. And to the east is the STA 5.6. That will be the only destination of water stored in the C-139 FEB. The FEB is situated at the north end of the C-139 annex. Pivoting from the yellow star in the previous slide and looking southwest to the top of the picture is what will be the footprint of the C-139 FEB. Currently, the major feature in this area is the G508 pump station, which is the primary inflow into STA 5.6. This water control structure pumps runoff from the C-139 basin into STA 5.6, which is shown here to the left and at the bottom. The current flow patterns allow runoff from areas to the west along the Deer Fence Canal and areas from the north served by this L3 canal and the L2 and the L2 West canals to be conveyed to this location and directed towards the G508 pump station. As the water is lifted by the pump station into the STA inflow canal, it flows into these and several other flowways to the south for treatment. Water that is treated in the STA is discharged into STA 5.6. The red outline is the approximate alignment of the exterior levees of the future FEB. Runoff from areas to the west, on the right side here, will be able to flow directly into the FEB, or alternatively, they may be pumped as they are today through the G508 pump station into the STA. Similarly, runoff from areas to the north along the L3 canal can also be pumped either into the FEB or into the G508, or through the G508 pump station into the STA, or both. Outflows, once the water is lifted into the FEB, it will take a long route guided by an interior berm before exiting the FEB. And those outflows will be conveyed across the L3 canal and into the STA inflow canal to gravity flow into flowways here and to the south. The schematic on the left shows the exterior levee alignment in the final design of the FEB that was recently completed. This interior berm guides the flow of water inside the FEB, and we can see the location of the inflow structure and the outflow gravity structure. This long route that the water will take before it exits allows for settling of sediment and for pre-treatment before that water is discharged for final treatment in the STA. Design also includes a seepage ditch along the south and west exterior levees to protect adjacent interests. And a structure along the Deer Fence Canal called the G711 structure will be relocated just to the east. And that seepage ditch will discharge downstream of that newly relocated G711 gravity structure. The FEB will have an approximate storage capacity of 10,500 acre feet at its maximum storage depth of 4 feet. The inflow pump station will have a maximum capacity of 690 CFS with 6 pump units, each of 115 CFS. This provides a greater flexibility for handling runoff. The outflow gated spillway is a 2-gated structure and also has a capacity of 690 CFS. Because of its size relative to the annual runoff volumes from the basin, the FEB is expected to fill and empty multiple times each year, and we'll be able to store runoff from the source basin and release water to the STA simultaneously. This table summarizes the results of the modeling presented in the 2012 Restoration Strategies Regional Water Quality Plan. Those results were based on modeling using the dynamic model for STAs, also known as the DMSTA. And based on a 41-year continuous simulation, the performance of the restoration strategies, STAs, and FEBs were simulated. For the western flow path, the C139 FEB and the STA 56 were simulated in tandem to allow the STA to meet the Q-bound. The table shows the inflow and outflow concentrations for the FEB and the inflow and outflow concentrations for the STA. The second and third columns show the minimum and maximum concentrations within the 40 water years of the simulation. But looking to the last column on the right here, it shows the average annual flow-weighted mean total phosphorus concentration. We see that the average inflow concentration into the FEB was projected to be 147 parts per billion, and the resulting outflow concentrations from, or average outflow concentration from the FEB was expected to be 59 parts per billion. The average inflow into the SDA was expected to be 117 parts per billion, and the outflow concentration after final treatment through the SDA was expected to be an average of 13.1 parts per billion, which fulfills the modeling QBEL check. Now, note that the average inflow concentration to the SDA of 117 represents a combination of two sources of water. One source is the flow directly from the basin at 147 parts per billion, but another source is the water that originates from the FEB at 59 parts per billion. The graph on the left shows the performance of the SDA for the last 11 years. The red trace shows the inflow concentration. The average for these 11 years is 188. I'm sorry, I have that backward. The blue trace is the average inflow concentration. It averages 188 parts per billion. The red trace is the outflow concentration, and it averages 46 parts per billion. Now, note that the last 5 years prior to water year 2017, or prior to water year 2018, had an average outflow concentration of about 24 parts per billion. The outflow concentrations were high in water year 2018, which included the record June rains and Hurricane Irma in September 2017. And those outflow concentrations have not come down to pre-2018 levels. This observed performance of SDA 5.6 represents a condition prior to the completion of internal improvements, shown here in this red box, to regrade non-effective treatment areas in cells 2A and cell 3A that were recently completed ahead of schedule in May of this year, and which are undergoing currently the required period of initial flooding and optimization. Also during this period, the SDA did not benefit from the expected lower inflow concentrations that will result from the operation of the future FEB. I'm pleased to announce that the consent order milestone for final design is ready to be signed off, since we have received on schedule the 90% final design from our consultant. A bid package is being prepared, and it will be advertised mid-October, with bid opening scheduled at the end of November. A resolution will be brought to the December governing board seeking your approval for the construction contract ahead of the consent order milestone due date, which is January 31, 2021. The current engineer's estimate for construction of this FEB is $100 million. The consent order for completing construction is December 2023, with a subsequent 1-year period for monitoring and testing. Finally, this picture was taken some time ago during the regrading of cell 3A of SDA 5.6, and it shows the hauling operation to move excess material from the SDA across the L3 canal to a stockpile location in the future site of the FEB for future use in earthworks for the C139 FEB project. And I'll be happy to take any questions.
Thank you very much, Jose. If anyone has any questions, And I see Mr. Steinle, you have your hand raised. Go ahead.
Thanks, Mr. Chairman. Thanks, Jose. Can you just go back to, let's see, page 9? I just want to talk a little bit, and I think you addressed it, but just to clarify, this anticipated benefit versus some shorter term or more recent data that we have. Okay, so we now have 5.6 operating without an FEB. The FEB would obviously provide a significant amount of efficiencies. So just, I want to make sure I understand this. This is the anticipated results. This is the forecast of the benefit at the 5.6 outflow with the FEB, with an annual TP of about 13.1. Do I have that correct?
Yes. So 13.1 is the outflow concentration of the STA after the water from the basin has benefited from settling of sediment and pretreatment in the FEB, and that water has gone through the STA. But in addition, other water has flowed directly into the STA from the source basin. So there's a blend, and the blend is about 2-to-1 ratio, 2 parts from the source basin and 1 part from the FEB. That blending produces this completed project inflow at the STA of 117, which is significantly lower than what the STA is currently experiencing on a long-term average.
Okay, understood. So, and I'm just looking at the dates of the data that we're using for this analysis. It's between, on the shorter term, it's about 10 years, 11 years ago, and about 15 on the longer term. So if you flip to page 10, obviously the data since 2009 is not reflecting what you pointed out, which is the growing concentration of outflow in the outflow concentration growing since 2017. So I guess my question is, do you still expect the same average results of 13 TP on average with this blip up in 17 to an average? You know, you see the 74, 55, 58. Is that what you were referring to in terms of the refurbishment of those western flowways? So I guess if I'm probably not asking the question clearly, but does the lack, are we considering years 2017 through 2020 in our anticipated benefit of 13 in the page prior?
Yes, in the page prior, the inflow concentrations from the source basin from a 10-year period of data represented the period after the regulatory program was in place and had produced results that are still current and are validated to be similar in the next 10 years after that 2000-2009 period. What we're looking at in this 11-year period is a combination of some years within the range of concentrations that we had seen as the average for the simulation, and some years that are above that average in the simulation. We would have to see what a longer period of record would produce with additional low concentration years and additional high concentration years. So it's hard to say how representative this 11-year period is when we compare it to a much longer period of record.
Okay, so can I go, I guess what I'm trying to get at is for the investment of approximately $100 million, the outflow levels average of a 13, you think is still realizable, even given the last 4 years performance of the STA?
Well, I think given that we did not have, we basically had those two flowways offline for a period of time between 2019 and 2020, and given that we do not know precisely how the FEB will assist in producing better inflow concentrations to the STA, we can only expect that these inflow concentrations would have been lower and that these outflow concentrations would have benefited from these two projects, restoration strategies projects being completed. Now, in addition to that, to ensure further, I guess, to obtain further assurance that we're doing all we can to especially address the issue of dryouts in this STA, we have a project that is in the feasibility study phase, which is a connection from Lake Okeechobee to this STA or to the FEB to bring water when Lake Okeechobee is able to send water south, and when both either the STA or the FEB has capacity to receive that water. And that effort, that study is not a restoration strategies project, is currently not funded, but we have a feasibility study that will end in December. And if approved, that project can be completed in about 3 years and could provide further assurance by extending the period of hydration and provide further assurance that the QBEL can be met.
One of the things, Mr. Steinle, that this is Drew, I'd point out is those projected numbers in the table for the outflows are modeled numbers. And so that's based on modeling that underpins all the other STAs and FEBs that we also have designed. And so you've got, and basically that model told us how big to make the FEB and how big to make the STA and how to make sure the STA works. And so the outflows for STA 3-4 and then the outflows for 3 of the 5 flowways for STA 2 are doing what the model predicted it would do. And so, you know, what you see in the table before is what we expect once we regrade 5-6 and build this FEB. And I think if you look at the A1 FEB, I think what the model predicted would come out of the A1 is higher than what is actually coming out of the A1 FEB. And that's also a 4-foot FEB. So, you know, the models are inherently conservative. And so I would, you know, all of this is based on our trust in that model, which we work on constantly, and it seems to be panning out in the other areas. We certainly will know, which is why we want to get all the construction done in 2 years ahead of 2025, so that we can do some testing and run through the FEB and through the repaired cells and through 5-6 in a means where we have FEB water to try to keep it wet for longer, and, you know, keep it operating optimally like we see over 3-4. So, you know, by 2025, we'll have a whole lot more data and information on whether we're achieving that 13.1 or not, but these are all modeled numbers. So I thought I'd point that out.
Gotcha. Thank you both.
Mm-hmm.
Thanks, Drew. Thanks, Mr. Steinle. Vice Chair Wagner.
Thank you, Mr. Chairman. Can you hear me okay?
Yes, I can.
Thank you. So this is a really great presentation, and obviously I think that it's been clear for some time that STA 5-6 has needed help. So conceptually, I think this is obviously progress towards doing what we need to do in terms to meeting the QBEL. A couple of concerns that I had, I was hoping that maybe you might be able to help me out on, Jose, with respect to, for instance, the 13 that's projected while we're on this screen, which is slide 9. The projected outflow from STA 5-6 at 13, and I say this because I think for anybody $100 million is just, it just pops off the page. It's a lot of money. 13 doesn't get us to where we need to be, does it?
The 13, it does get us to where we want to be. The DMSTA produces output, and that output is processed in a conservative way. So when that result is rounded to 13, in other words, 13.4 or below, then that is assumed to meet a modeling Q-Bell check, which is a surrogate for the actual two-part Q-Bell, which is a 5-year rolling average, not to exceed 13 for more than 3 years, and an annual maximum of 19 parts per billion. So those two, that real test, cannot be simulated with precision with DMSTA, but this 13.1, which is a simulated surrogate for that, is the check that this works.
Okay, because I've been operating, at least mentally, off the number 10 for some reason, and maybe I'm just totally off base.
So, Mr. Wagner.
Yeah.
This is John Mitnick. Let me jump in here for a second. So, yes, that's a common, I guess, point of confusion with different folks. And everybody's used to hearing the 10 parts per billion.
You can say misconception. I'm not insulted by it.
So yes, 10 parts per billion is out in the marsh. So what the permits that the Water Management District holds from the Department of Environmental Protection requires to meet that Q-Bell, that water quality based effluent limitation. And that number, as Jose was starting to describe, is 13. And then there's another second part having to do with 3 out of 5 years. And I won't confuse people even more by getting into that piece of it. But to answer your direct question, yes, this gets us where we need to be in compliance with our permits from the Department of Environmental Protection.
Okay, that's good. That definitely solves that little, bridges the gap I had there in that analysis. Can we go to slide 10, please? Okay. So when I looked at this chart here on the left, it looks roughly, with my, sort of eyeballing it, that between the years 2010 and 2013, we were roughly around 135 to 140 on average in terms of total TP. Is that about right? Parts per billion? Looks like the inflow is at like 135.
Inflow probably in the order of high 180 or around, I would say around 180, 190 parts per billion for the inflow.
Okay, because what about for the years, like when I look at this for the years 2010 through 2013, it sort of bumps from 150 to like 125 to 150 to 125 for those 4 years, right?
Oh, yes.
Okay. And then from after 2013, we see this massive uptick, and then it sort of bumps along at an average of about 200 parts per billion for the next 7 years.
Yep.
Did something happen to cause that? Do we know why we're getting so much more inflow of TP in the years between 2014 and 2020 as opposed to 2010 to 2013?
And if Carmela's still on, she could probably answer that a little better. She's, very familiar with all this data.
Hi, this is Carmela.
Hi, Carmela.
Hi. There are definitely differences from year to year because of rainfall, and the focus on the basin is load. But just to give you an example, from 2018 to 2020, the rainfall levels that the basin has had have been much higher than normal. With 2018 being at 69 inches of rainfall, and even in 2020, although the basins more to the east had lower or more normal rainfall levels, our rain gauges indicate that in the C-139 basin, they were above average, around 57 inches, which starts getting a little bit high. And all these take us to the big help that the C-139 FEV is going to be, in that this basin has very little tolerance to high rainfall events. So it is just how intense a rainfall event occurs at the right time that is just going to bring the concentrations up. While at the same time, you may have years that are, you may have higher rainfall, but you may have a 2019 where you were around the 150, which is a relatively good concentration. So
yeah, I'm trying not to look. One thing I've sort of learned is that it's difficult to look at years in a silo. I try to look at kind of these rolling averages, and it just seemed to me that it looked like something happened. Like we were bumping along between 2010 and 2013, you know, year after year, a little bit up, a little bit down, but generally in that 140 range. And then in 2014, for the last 7 years, we went all the way up to kind of the 200 range, which is a really large increase to me in terms of the parts per billion of phosphorus that are getting in. I mean, we're already sort of in a little bit of a problem area to begin with this STA. I was just curious, does the district look at this and say, well, it's just a factor of rain, or is there something else going on that we need to be mindful of? Because it seems to me, obviously, we're building $100 million projects here to sort of remediate the amount of phosphorus we're receiving, to get it on the, I think you called it the treatment train. But my question is there something we also can be looking at bigger picture in terms of helping to reduce the amount that's coming in to begin with? It just seems like something happened. I don't know whether there is or not, but it does seem like we just kind of went up in 2014 and never came back down.
Yeah, based on our follow-up of the basin, it's not that we see any major changes that have occurred between then and now, but certainly you make a very good point in that, you know, continued close attention to the activities and boots on the ground, just because although the numbers may look like a big difference, it may not really reflect a huge systemic change, but just something that happens at a time that may affect the levels. But that is definitely something that we should follow up on.
Yeah,
also,
because
I think I cut somebody.
Yeah, because I do take fellow board member Steinley's comments. I thought they were very good about, because I think the modeling study that was shown was a 2012 modeling study. Yeah. And at the time 2012 was there, we hadn't seen this spike. We had been bumping along generally at the 140 range, which had then predicted if we put all these things in place, we'll get down to 13, which is kind of like we just get our nose across the finish line at 13. So now that we've seen this spike, I think maybe Jay had asked for this specifically. I don't know, but it would be nice to know whether the implementation of what was thought to be the project we needed in 2012, when the numbers were at 140, still holds with the numbers now at 200. I'm a little bit afraid, and I'll just say it out loud. I mean, it frightens me to say that we would spend $100 million and not get across the finish line. That just inherently scares me. You know, I feel like if we're going to be spending $100 million on a particular project, like I'd like to get there, you know? And so I don't know whether whether this is a time or how long these kind of things take in terms of analyzing it, but there does seem to be a jump, you know, after the model was put into play.
That's what it looks like to me too. What I don't know is what the model inputs are. I'm still trying to, can you go to the previous slide? Are those the model inputs? So yeah, it's around one.
Yes.
It averages around 147 on the FEB inflow. So that's very different than 200. What I'm curious about as to whether Carmela was, you know, her focus on load versus concentration is something we should look at, but we definitely need to engage Walter, his modeling team on what our expectations are here.
Ms. Reynolds, you have something you'd like to say?
Yeah, so I just was going to jump in that I understand the concerns, and we'll be able to bring to the board some more clarification to help answer some of these questions. But we really, if you could go back to slide 10, one of the most significant aspects of this basin in particular, but several of these basins in that western flow path, is the correlation between the concentration and the rainfall. And so this is actually almost not a long enough time period to really help illustrate how significant that relationship is. And that's part of why an FEB in this area is such a critical portion of making STA 5.6 optimize its operations. Yeah, and so as we talk about these projects in the future, I will make sure that we bring additional information to help answer these questions for the board as we continue to talk about these projects.
Jennifer, thank you very much. I am certainly not gun shy about doing the flow equalization basin. I mean, it's certainly everything that's been presented clearly goes to the heart of, you know, helping STA 5.6 do what it needs to do from a variety of different functions. I just want to make sure that before the train leaves the station, at least for me, you know, it'd be comforting to know that it doesn't need to get beefed up. Do we need to give it, you know, something else to help? Is there more we can do? Or is this the best, you know, this is the best we can do? And are there other areas that we should be looking to in order to try to help control the inflow of TP, you know, while we make $100 million investment to get STA 5.6 to do what it needs to do? Is there something else we can be doing in tandem to kind of reduce the inflow TP to make sure that this, you know, $100 million investment works the way that we need it to?
Absolutely. I understand. And you're exactly right that the assumptions in the model don't necessarily reflect all the other activities that have to do with source control in these basins, and don't necessarily reflect all of the activities of not just the Water Management District, but the efforts that are ongoing with the coordinating agencies as part of the activities and projects that the Water Management District, DEP, and FDACS are all working together in order to achieve water quality benefits.
Yeah, it would be very good to have, you know, us firing on all cylinders with all agencies to kind of, you know, get everybody running in alignment so we can hit, you know, obviously get below the Q-bell. I mean, the Q-bell is the highest we could be. Nobody says you can't go lower, you know. It'd be nice to be low.
Thanks, Vice Chair Wagner. Mr. Steinle, that was a good conversation. Jose, I think I got a question. It might be for you, and it goes to what someone just mentioned, which is a connection to the lake. I understand we have a problem hydrating 5 and 6 right now during the dry season. Will this FEB take care of that, or is it, we don't know yet?
Well, the FEB probably is able to fill and empty about on a good year probably 5 times, and so its volume being 10,500 that means it can fill up maybe to or store and release about 50,000, maybe 60,000 acre feet per year. What comes in from the basin is approximately, I think in the simulation, in the order of 200,000 acre feet. So what the FEB can do is it can take that first flush, especially after a dry out period. This basin is notorious because for many months, there is no inflow into STA 5.6. Usually it can happen for 6 or 7 months during the dry season that there is little or no inflow to STA 5.6. And then the rains happen and that basin stores the water. And when it's saturated and its internal storage is full, then it starts to release into the conveyance canals. And it's that initial flush of water, which we've seen this year, that produces high flows with very high concentrations, both inflow concentrations and outflow concentrations from STA 5.6. Those outflow concentrations are affected not only by what's coming in from the source basin, but the condition of the STA itself. After being dry for many months, it's not really in a condition to receive and treat that water. So the FEB does a couple of things. It softens that impact of especially the rains that come in at the beginning of the wet season, but also if it can sustain the dry season flows longer to have the desirable vegetation in these flowways, because this is a large STA. And so for many months, it needs to be hydrated and not to dry out to perform well when the flows come in. So the further assurance to make sure that we minimize that effect of dry out and that we have an STA that's ready to receive flows and concentrations that are variable and that may be high at certain times is this connection to Lake Okeechobee. And that is going to help give further assurance beyond what the FEB is going to provide by itself, which is significant and should meet the QBEL. But if there's any level of further assurance that we would like to have, it's that connection to Lake Okeechobee that's going to provide that further assurance.
Thank you very much. I appreciate that. I don't see any other hands raised. So Jose, thank you very much. We'll move on now to section C, which is the Western Everglades Restoration Project. Mindy Parrott, Lead Project Manager for Ecosystem Restoration and Planning Bureau.
Good afternoon. Thank you for this opportunity to talk to you about the Western Everglades Restoration Project, otherwise known as WERP. I'm the district's project manager for the WERP, and I'm going to focus today on how the WERP may affect the C-139 Annex and the L-28 basins that you've heard about previously. WERP is different than the projects you've heard about earlier today in that it is a planning study. So it is still in the planning phases as opposed to the FEB, which is nearly ready to go to construction, and the Sam Jones Abiaki Prairie project that is already clearing land and making progress on restoration. So you've seen this slide before. I just wanted to remind you of the area that we're talking about for the Western Everglades Restoration Project. You just heard about the C-19 FEB, and to the south is the Sam Jones Abiaki Prairie Restoration. WERP would include an STA in the area that is currently labeled as leased agricultural lands. So as I mentioned, WERP is still in the planning stage. It's a feasibility study under the Comprehensive Everglades Restoration Plan. District staff are working with our partners at the U.S. Army Corps of Engineers to study the the environmental and economic and other effects of changes to the CNSF system in this area. The area that we're talking about for work includes the C-139 basin, which in this graphic is right here, the North Feeder and West Feeder canals, the L-28 Interceptor Canal, the L-28 North Canal, as well as the L-28 South Canal. Also, major features in the study area are the Seminole Tribe Big Cypress Reservation and the Miccosukee Tribe Alligator Alley Reservation right here. So the objectives of work have to do with restoring hydrology, hydroperiods, decompartmentalizing pieces of the Everglades by altering parts of the CNSF system, restoring water levels to reduce wildfires associated with altered hydrology. While fires are a natural part of the ecosystem, this area is subject to some sometimes devastating wildfires. So work aims to help improve this situation. Another objective of work is to improve and restore habitat by reducing nutrient loading to improve water quality. So I'll just point out a couple more things on this graphic. This is the Big Cypress National Preserve in all of this area, and this would be Conservation Area 3A. So the WERP study began in 2016. Currently, the WERP team is evaluating alternative HR, which is the alternative supported by the team and many stakeholders. We anticipate that we will reach the TSB milestone, or the tentatively selected plan, in March of 2021. Prior to that, work will be presented to the governing board for your input, likely in January of 2021. There will be additional opportunities to discuss and provide input for work as the draft and final project implementation and environmental impact statement documents are released for agency and public review in May and December of 2021. Ultimately, the goal is to complete the study in March of 2022 in hopes of being included in WERDA 2022. On the left is a graphic depicting alternative HR. While this graphic is difficult to see on a slide, what I hope you can take away is that the project involves a very large area and that there are proposed changes to the CNSF system and additional features within several areas, one being the C-139 Annex, and another being the West Feeder Canal area, a third being the L-28 Interceptor area. This is I-75 for reference. And the last area is down on the L-28 South. This is Tamiami Trail and 40 Mile Bend. So today I'm going to focus on the L-28 and the C-139 Annex, because this is the C-139 Annex workshop. So here on this map, I'll just point out a few features. This is the West Feeder Canal. This is the North Feeder Canal. Together, they meet at S-190 and continue as the L-28 Interceptor Canal, which continues south of I-75 into the Water Conservation Area 3A. This canal here is the L-28 Canal, and it takes a similar path south past I-75 and creates what's known as the L28 triangle. This area is part of Big Cypress National Preserve, and Conservation Area 3A is this area in here. Currently, runoff from the feeder canal basin enters the L28 interceptor via the north feeder and west feeder canals. Coming through here. These flows over the years have resulted in an overgrowth of cattail in Conservation Area 3A within the Miccosukee Tribe Reservation. As you can see from this inset, the cattail glows green on an aerial photo. There's a similar area associated with S140, which would be right about in this area here. Additionally, the L28 interceptor has a large drainage effect on Big Cypress National Preserve. South of S190, this structure here, the canal just flows openly and the ground elevation difference is about 5 feet, meaning this canal is intercepting the groundwater and draining it into Conservation Area 3A. So WRP's alternative HR proposes several actions to address these issues and improve these conditions consistent with WRP objectives. First off is filling of the L28 triangle canals and removing the levees. This will improve connectivity, restore hydrology, decompartmentalize the system, and improve and restore habitat. There is also included vegetation restoration in the 2 areas I mentioned that have experienced cattail overgrowth due to nutrient loading. The L28 would be blocked off from flow so that no flows would leave the canal, and there would be a weir installed to better manage that water as it's coming down the canal. Effectively, the L28 interceptor would be converted into a retention area. In order to do this, most of the flows coming into the interceptor canal must be reduced, and this is accomplished in alternative HR by features upstream of the west feeder and north feeder canals. So here we are back on the annex. So in order to reduce those flows, the north feeder basin, subbasin, would be intercepted by placing a block on the north feeder canal and pumping the water into the STA proposed on the C-139 annex. The water, once it's treated, would flow through a canal parallel to the L3 canal inside these Pond 5 North and Pond 5 South before reaching a structure that would route it to the L3 canal. It will then make its way into the northwest corner of Water Conservation Area 3A. The district is currently working with our federal partners to make sure that these changes do not have an adverse effect on the Abiaki Restoration Project. Similarly, there is a STA and flow path that directs the west feeder flows from the L28 interceptor into an STA and into the Kissimmee Belly Slough. So that's all I have for you today on WRP. I'm happy to answer any questions. And as I said earlier, we will be back to present you the entire work project as we get closer to the TSP milestone.
Thanks very much for that presentation. Let's see, I've got 2 hands up. Drew, is yours up from last time? Or is
no, it's up. It's up for this. I appreciate it.
Why don't you go ahead first, and then we'll go to Colonel Roman.
Okay. Mindy, would you mind going back to the map that has the full view of WERP? Let me see if I can tell you what slide it is. Slide 3. There you go. So Mr. Bergeron wasn't able to make it today, but he wanted to make sure that if he were here, he would have pointed this out to you because he's been talking a lot about it with me and John Mitnick recently. But on the southern end of that map, you see on the right side is Water Conservation Area 3A. And 3 of the projects are those white dashes, which are new culverts in the L28 canal that can let water out of 3A when it's high over into Big Cypress and underneath US 41 and Loop Road to the south, down to the 10,000 Islands. Those 3, right now we're doing everything we can to uncork Tamiami Trail on the southern side so that we can better manage water levels in 3A. We have current high water levels in 3A. Those 3 culverts he estimates and John estimates to be $4 to $5 million for 3 culverts. So, and that would get an additional 1,500 CFS out of Conservation Area 3A. So right now, there is not a tentatively selected plan that has been finalized as part of Western Everglades, but he is very much championing and asking me to engage the Corps of Engineers on what we would need to do to move out on those 3 culverts ahead of schedule. Right now, there's still some modeling that needs to be done to see if any changes need to be made to US 41 with those additional flows or not. So we still have a little bit more analysis to do for the next half year, maybe quarter to half year. But he wanted to make sure that the board saw that as an opportunity for better managing water levels in 3A and getting necessary flows down to the 10,000 Islands. So just wanted to point that out to you on behalf of Mr. Bergeron.
Thanks, Drew. Is that something that can be done in an expedited manner, or would it have to go through the whole process of WERP and the authorization?
If you want to do it as part of SERP, then you would have to wait for a tentatively selected plan to get finalized, which should happen maybe a year from now.
Got it.
And then you could sign a PPCA and get credit. The other option would be to move out ahead of schedule and not get credit under SERP.
Okay.
Yeah.
Thank you.
Thank you.
Colonel Roman.
Yes, thank you, Mr. Chair, and thank you for the presentation. I wanted to make sure that I understood the changes to the L28 interceptor and whether those changes are the sole focus of keeping the Big Cypress National Preserve from being overdrained. Correcting the hydrology, I guess, would be a better way to say it. If you could address that, please.
Sure, that's certainly part of it. It is removing the drainage effect will help restore the hydrology in the north and northeast parts of Big Cypress National Preserve. But part of what I didn't talk about today is on the, I don't know if you can see my pointer, but the L28 South features that Drew was just talking about, these 3 structures. Also included is the removal of the L28 tieback, which is kind of an orangey stripe north of those 3 structures. Yeah, right there. Thank you. Removing that levee, that tieback levee, will allow water to flow in the natural S curve that you can see kind of in the background aerial photo. Naturally, the flows from Big Cypress come down south and then move southeast, but they also curve back to the southwest. And that tieback levee kind of prevents that southwest flow from happening. So one of the things that work proposes to do is to degrade that levee and allow those flows to move in that more historical path. In addition, the culverts that Drew just spoke about will also create a better balance between Conservation Area 3A and Big Cypress National Preserve.
Great.
Thanks. Let's see, Ms. Meads?
Just to respond to what you said, Drew, I just would like to say out loud that for a price tag of $5 million, I would be very interested in exploring the possibility of expediting those culverts.
Thank you. Yeah, it sounds a lot better than 100 million, doesn't it?
Yes.
You're just setting us up. Is there any other board member who has any comments on this?
Yes, I had a comment, and we probably would want the staff to also look at that tieback levee, if that's part and parcel to that flow correction, as was just explained to me, or at least that's what I took away from it.
That makes sense.
Because to me, they both go together.
That makes sense.
Thanks. Any more comments from the board? Any more questions? I have one, and I apologize for being sort of out to lunch on this one and not just having this question now. It goes back all the way to the Sam Jones Abiaki Prairie projects, and that discussion. What are we looking at for dates of completion on those?
Hi, Chairman. This is Jesse Van Eyck. I think I can answer that. So our completion date for the restoration project is scheduled for 2028. And that is all the construction will be done and the bulk of our plantings will be done. There'll be a period of I'll call it a burn-in process for about 5 years where we have to monitor and check and make sure that the plants are taking off after that. But the construction will be done by 2028.
Great, thanks very much. If there's no other discussion by the board, I'd like to thank the staff very much for the presentation. I'd like to go over to public comment now. And members of the public, if you'd like to speak, you can raise your hand using the raise your hand feature in Zoom. And if you're using a phone and you'd like to comment, please press *9 to raise your hand and then *6 to mute or unmute yourself when you're called upon. There's going to be a 3-minute comment guideline for the workshops. You'll see the timer on the screen, and we appreciate your holding true to that. And Rosie, we'll see if you've got anyone logging in for questions or comments.
I do, Mr. Chairman. I have a phone call-in with the last 4 digits of 5372.
Yes, hello. Can you hear me?
I hear you.
Yes, my name is Drew Martin. I'm Conservation Chair for the Lakeside Group of the Sierra Club and also a member of the Florida Sierra Club Chapter Conservation Committee. And I just want to first thank the staff for the excellent presentations. And I think, although this is expensive, I think this is an important step forward. So I think the board should seriously pay attention to the recommendations that they're being presented with. And I mean, meeting the cue ball is very important to the Florida Bay water quality. And if you don't meet the cue ball here, that means you're going to have trouble sending the water south of the bridge without violating the court orders. So that's why the district was given the taxing authority it has, so it would have the revenue to do these sort of projects. May have to extend it a little, but I think it's important. We see how important it is to get water south in order to alleviate the flooding in the water conservation areas. And we know how important we want to keep toxic water out of the Gulf of Mexico. We saw all the algal blooms, red tides, and all the death of species a couple of years ago. We don't want to move backwards. We want to continue to move forward. So I know that this is an expensive project, but I think we should seriously consider what the purpose of the water district is and why it was established. And one of the reasons the South Florida Water Management District was established was to do these sort of projects. Thank you.
Thank you, Mr. Martin. Mr. Chairman, I do not see any other hands raised, but if we can give just a few seconds, maybe somebody is having trouble accessing the raise hand feature. There are no additional hands raised, Mr. Chairman.
Thank you, Rosie. And I'd like to thank the staff. Those are really excellent presentations. And I think it helped us a lot. Those are areas we have not talked about since I've been on the governing board, and it helped me quite a bit understand the big puzzle that we're looking at and put some puzzle pieces in there, and I appreciate it. I don't see any hands raised from any of the board members. So if you don't have any further comments, we're going to go ahead and adjourn this meeting. But before I do, I want to remind you that we do have 2 public meetings tomorrow. We have a 9 o'clock governing board regular meeting and our monthly business meeting. And then at 5:15, we're going to have a budget hearing, and both will be via Zoom, and we'll use the same Zoom link. Or I guess they will use the same Zoom link, and members of the public are welcome and encouraged to join both meetings. Thanks very much, everyone, and we're adjourned.